applied data science project predicting restaurant success with Yelp dataset by Shai Dekel and Sachi Elbaz. Yelp is an American company. It develops hosts and markers. Yelp.com, which is a crowdsourced local businesses review and social networking site. The site has pages devoted to local businesses, restaurants, or schools, where Yelp users can submit a review of their products or services. Businesses can also update contact information, hours, and orders. According to the Sterling Market Intelligence, Yelp is one of the most important sites on the internet. Yelp Challenge is a chance for students to conduct research and analysis on the data and share their discoveries. The Yelp Challenge is a huge dataset that includes 48,485 businesses with details and 2,577,298 reviews, minimum 3 reviews for business and up to 6,414 reviews, and also check-in count for every hour. Suppose that someone wants to open a new restaurant. He may have an uncertainty if the restaurant will succeed. We suggest an algorithm that is able to predict the number of Yelp stars, success rate of a certain restaurant given its characteristics. These characteristics, called features, contain relevant information about the restaurant, such as its location, opening hours, kind of food, facilities options, logistics, parking, etc. In addition, the algorithm is also able to analyze and visitor text reviews by extracting a score that indicates how positive or negative is a certain review based on sentiment analysis techniques. These scores have a substantial contribution to the prediction process. The features are basically divided into two main fields. The first one is the given features, such as food categories, attributes, bike parking, smoking area, music, alcohol, TV, etc., and checking information. The second one is feature generation, which is feature engineering working to extract a new feature that have more meaningful values and might improve the predictor performance, such as clusters, by clustering the longitude and latitude GPS positions, number of restaurants in the vicinity of a certain radius, opening hours in each day, text review, mean score. The first part of the work is getting started, viewing the data. We perform statistical analysis in the data. Statistical analysis is a component of data analytics in the context of business intelligence. Statistical analysis involves collecting and structuring every data sample in the data from which samples can be drawn and describe the nature of the data to be analyzed. In this plot, we can see the distribution of Yelp stars. We explored the relation in the data. For instance, in this plot we discovered that some features have correlations with the number of stars. In this part we described feature engineering working. Feature engineering working is a way to extract new features that have more meaningful values and might improve the predictor performance. The dataset contains textual categories and attributes. Categorical variables are also known to hide a lot of information in the dataset. We converted the categorical variables into numerical values, then transformed these numerical values to sparse representation using one-hot encoder. One-hot encoder. The purpose of one-hot encoder is to provide categorical integer features. The input to this encoder should be a matrix of integers, denoting the values taken by categorical. The output will be a sparse matrix where each column corresponds to one possible value of features. It assumes that input features take values on integer 1 to n. We also converted the longitude and latitude GPS positions of the restaurants into K clusters. We used the K-nearest neighborhood algorithm. K-nearest neighborhood is a non-parametric method used for classification and regression. The input is the accurate GPS positions of the restaurant, longitude, latitude. The output is a class membership that based on the majority vote of its integers. In this plot, we can see the location clusters distribution. we perform several experiments and choose k equal to 15 clusters. How many restaurants in a neighborhood? We discovered that the number of restaurants in a vicinity of a certain radius has a significant influence on the number of stars. We then extract that information from the data and use it as a feature. We believe that the amount of visitors at the restaurants also influences the star predictions. To this end, we created a feature table showing the number of check-ins of the restaurants at every single day over the week. This information is also extracted and incorporated as a feature. We use the reviews dataset. Each restaurant contains several visitors' text reviews that describe the visitors' experience from that restaurant. We predict a score from each text review in the database. This score indicates how positive or negative is the review based on sentiment analysis techniques. The average text score were calculated for each restaurant based on its reviews. During the training, we discovered that this average score has significant contribution on our prediction results. Sentiments analysis. Generally speaking, sentiments analysis is a technique that aims to determine the attitude of a speaker, writer, or other subject with respect to some topic or the overall conceptual polarity or emotional reaction to a document, interaction, or event. We used a knowledge-based technique that classifies text by the affected categories, based on the presence of unambiguous affect words such as amazing, bad, good, or poor. Some knowledge techniques based on list of obvious words called dictionaries. To this end, we use the Python NLTK library and some positive and negative dictionaries that associate to businesses. Data cleaning. We remove unused information such as nouns, addresses, names, etc. Dimensionality reduction. We perform a dimensionality reduction using PCA, Principal Components Analysis. The PCA is a linear mapping of the data to a lower dimensional space in such a way that the variance of the data in the lower dimensional representation is maximized. We discovered that from 1,500 features, the most 150 features are the most important. In this slide, we describe our predictions and the results. Finally, we have 1,077 features and 46,470 observations restaurants. We divide our dataset to training and testing using train test split of Python SK library. We have examined 4 regression predictions on our dataset: random forest, linear regression, decision trees, and neural networks with 3 layers. Here is our best result: random forest with mean absolute error of 0.388. Linear regression with mean absolute error of 0.490. Decision tree with mean absolute error of 0.4. And finally, neural network with mean absolute error of 0.4. Thank you for listening to our presentation.